Hello. In this question, we should provide a detailed mechanism for acid-catalyzed hydrolysis of this cyclic ester. In the presence of acid, the hydrolysis of this cyclic ester yields this structure containing alcohol and carboxylic acid groups. As we know, esters form from the reaction between a carboxylic acid and an alcohol. And in the hydrolysis reaction, we should recover those alcohol and carboxylic acid groups as you see in this reaction. Now let's consider the mechanism. In the first step of this mechanism, the red oxygen is protonated by hydronium ion because we have acidic condition. And then we have formation of this intermediate. But the question is that why between the red and blue oxygens, just the red one is protonated? The answer is given based on the resonance form. If we transfer this lone pair here to make a pi bond, and then the pi bond of carbonyl group must be broken, and its 2 electrons come over oxygen. So in the resonance form, we would see that the red oxygen has a negative charge. So this is the reason that the red oxygen is more basic than blue oxygen. So the red oxygen is protonated. After protonation of red oxygen, now this carbon of carbonyl group becomes a stronger electrophilic center than before protonation. Why? Because here positive oxygen is more electron greedy than neutral oxygen. So here this oxygen plus makes the carbon of carbonyl group stronger electrophilic center, and in the next step this electrophilic center is attacked by nucleophile, which is water, to form this intermediate, and then this OH is deprotonated by water. Water functions as a weak base to form this intermediate. In the next step, this carbon oxygen bond must be broken to have a linear structure. However, carbon oxygen bond is a relatively strong bond. So in order to cleave this carbon oxygen bond more easily, we should protonate the blue oxygen by acid. Again, we do have acidic condition. And then after protonation of blue hydrogen, we get this intermediate in which we have a perfect leaving group, which is OH. Now this lone pair of oxygen, the red oxygen comes here to make a pi bond, and this carbon-oxygen bond must be broken to form this linear structure. In fact, this lone pair of oxygen here functions as a driving force for cleavage of this carbon-oxygen bond. And then after formation of this intermediate, this OH bond is deprotonated by, again, a weak base, which is water. Why we do need a weak base? Because here we have a strong acid. When we have OH in which oxygen is positive, that means oxygen would like to lose its proton more readily than when it's neutral. After the protonation of this red OH, we get the final product in which we have both alcohol and carboxylic acid groups in the same molecule. Why? Because we started with a cyclic ester. Thank you very much for your attention.